Hey math students, today we're going to talk about trapezoids. To the person who made these notes, I apologize. If I need to take them down, please let me know, but kind of in a bind here, so let's go ahead and get started. Okay, so a trapezoid, and you may need to pause. If I go too fast, please pause. A trapezoid is a quadrilateral with exactly one pair of parallel sides. And you can see the parallel marks on the bases. If the legs are congruent, trapezoid is an isosceles trapezoid. We know that word from isosceles triangles when the legs were the same length. Well, this is an isosceles trapezoid instead. Again, the legs are the same length. Another thing to note about these trapezoids is if it's isosceles, then the base angles are congruent to each other. Each pair of base angles is congruent. And I mean each, because this pair be congruent to each other as well. If a trapezoid has one pair of congruent base angles, then it is isosceles, which, if we write this rule backwards and forwards, then it's true both ways. We get the if and only if. It's isosceles if and only if the base angles are congruent. And so first we're going to have a kite problem. That's kind of silly that it's thrown in here, but let's do the kite problem. We are being told that BCD is 98, which is that angle at C. ADE, A to D to E, so right here is 47. If I mirror it, that's also 47, and that's 98. And then the other thing we know about kites is that their intersection here of the diagonals is perpendicular. We got 90-degree angles there. So finding DAE is our first problem, and if I'm just looking at that triangle, I've got, and I have 47, which is 137, and I can subtract that from 180 to get the missing angle, because the insides of triangles add up to 180. So I've got 43 right there, and I can mirror it across the kite right there. Then it asks us to find, so hold on, give me a second, 43. It asks us to find BCE next, which is here. So if I know that that whole angle is 98, I can subtract the 43 that I just found and get 55 for this chunk. And I mirror it. And then, let's see. And then the last part is they want us to find this angle. Whoops. Wanted that to be in a different color. Which is fine. No big deal. We know this is 98. We know this is 98. And we know this is 47 plus 47, which is 94. It's the two 47s added together there. And the inside of a quadrilateral adds up to 360. So we're going to do 98 plus 98 plus 94, which I believe is 290. Then we do 360 minus 290, and the missing angle is 70. Okay, back to trapezoids. It says find the measure of angle J, so that's the one I want to find. And if it is isosceles, which we know it is based on those side marks, then that's also 124. So this is where I do some calculus, not some actual calculus, just some math where I'm like, okay, all right, let's think about this. How many degrees have I used? I've used 248. And that means in a trapezoid where I have 360 degrees total, I have 360 minus 248 degrees left, which is I believe 112. The other thing I know is that this pair of base angles are equal. So I have 112 degrees, and I have two angles to split it equally between, and that means angle J and angle M are going to be 56. Problem asks for angle J, and we have it. Okay, so this one's kind of actually a rule that they didn't mention yet. We know that these sides, again, that this is an isosceles trapezoid, it's just turned on its side. And they also tell us that this length right here is 9. Well, it turns out that in an isosceles triangle, or isosceles trapezoid, the diagonals are equal to each other. So if I'm trying to find AG, and this whole length is also 9, it's just 9 minus 6.2. 6.2, which is the 2.8 that's left to add up to 9. That one shouldn't be too bad. On this one, the only thing that might worry some people is the squareds, but that's fine. These two angles are equal to each other. So 5x squared plus 32 equals 7x squared. And we do this problem like the squareds weren't there first. Minus 5x squared. The squareds are only a problem at the end. Get 2x squared. Again, if squared wasn't there, then I would divide by 2. 16 is x squared. And now that the squared is the only thing left, we say, okay, when I did the Pythagorean theorem, what I did to get rid of squared was I square rooted, and x is 4. So x equals 4. That's all that. The only thing that was weird was the squared. Everything else should be good. And this one, we just got done saying that the diagonals are equal to each other. We get told in the instructions that got cut off to assume that they're isosceles. So 2z plus 9 equals 4z minus 3. We're going to subtract 2z. 9 is going to equal 2z minus 3, add 3. 12 is going to equal 2z, and we will divide by 2. Again, I apologize if I'm going really fast. I just want to make sure we get this video done before first period, because I am not there today. So, we got a couple more rules, a couple things to go through, and we're almost there. So, there is something called the mid-segment of a trapezoid. And the mid-segment is, we got a point halfway up one side, we got a point halfway up the other side, and the mid-segment is the segment that connects them. In a trapezoid, we typically have one shorter side and one longer side, and the mid-segment is the average of their two lengths. So, mathematically, I can get it by adding the two bases together and then multiplying by 1/2. If you are still writing, you can pause because we're going to flip to the next problem. So, basically, the idea is we add the two bases, 16 plus 26, and then multiply by 1/2. 16 plus 26 is 42. Half of 42 is 21. The length of KL is 21. And that's all there is for that problem. It's really easy when they give us both bases, which means, of course, on the next problem they won't. And so we actually have a missing base. So we're saying, okay, if I add the two bases together and then multiply by 1/2, I get 7.5. 1/2 times x plus 5.5 equals 7.5. Now that's an equation. I can solve an equation. A lot of people have forgotten, or at least yesterday they had forgotten, that I can undo 1/2 by multiplying by 2. That cancels. And then I can drop the parentheses. X plus 5.5 equals 15. Subtract the 5.5. And it turns out that to get a mid-segment of 7.5, X, the other missing side, would have to be 9.5. We're going to do this again here in 2 problems. But back to the first method, we've got both bases. We do 1/2 times 14 plus 4.3. Yeah, that means we're going to get a decimal, and that's okay. Half of 18.3 is 9.15. Really, and again, if I have the 2 bases, I add them together, multiply by 1/2. I know this sounds like it's happening really fast, but pause and rewatch, do what you need to do. And then now we're back to one where we have an unknown. I know we already have an X, we're just going to ignore that. Unknown base, so 1/2 times the X base plus the 35 equals 22.9. And we multiply by 2 again. Cancels. X plus 35 equals 45.8 minus 35. So X would have had to be 10.8. 2 more problems, and if you made it on the video, you're kind of getting rewarded because the next 2 problems are actually problems straight from your assignment too. So we know that in a kite, the 137 that's in this wing of the kite is going to mirror down to here. We know that if I've got the same symbol, that those 2 angles are mirrored as well. They're not mirrored, but they're the same, they're congruent. And then we know that if we have the sides right there, we have the base angles are congruent as well. So we're going to be able to find everything we need to find for this problem. In the kite, it adds up to 360 on the inside. So we got 137 plus 137, whatever that is. That's 296. And then we subtract from the 360. So the missing X is going to be 64. And then on Y, we had the 2 angles here. We know that this also adds up to 360. We've used whatever 137 plus 137 is, which I believe is 274. We subtract from 360, and we get, trying to do this in my head, 86. We have 86 degrees left. Divide it to separate between the 2 bottom angles here. Each one of them is 43. 43, 43, y equals 43. And that's it on that. So, one more problem. And we're back to the kites. We've got our perpendicular intersection. Mirror this stuff just in case. It's going to be relevant here in this triangle, because now I can find y. I can do 90 plus 41 is 131. 180 minus 131 is 49. So found y already. And then actually the top triangle here, whoops. Seeing if I can write here, something's up. Having pencil issues there. Again, it's going to be 78 plus the 90, which is 168. And then 180 minus 168 is 12. So x is 12 degrees. And that's it. That should be the last problem from your notes. We're going to do the family tree on the back another time. And then you should be able to finish the assignment. So I know the video was long. We had a lot of examples to get through, and I wasn't here to give them to you in person. Good luck, and I will see you guys again in the next video.